Okay, we're looking at example 4 from section 7.1. Got a different colored marker here on this one. So the goal here is to realize that we're going to use the power rule, but in order to use the power rule, we have to realize that we can only use it on power functions. So the first step here is to try to rewrite this thing so that it is all power functions. And the best way to do that is to first realize that anytime you see a root, you're going to always write that as a fractional power. And then the second thing to realize is that if I've got two or more things added or subtracted in the numerator divided by whatever, then I can always split this up as two separate fractions. So these are the two things I'm doing, splitting it up and writing the radical as a exponent. Okay. So there's our split up function, and now what we're going to do is, in order to fully write this as power functions, I want to use the properties of exponents to simplify this. So if I've got x to some power divided by x to some other power, remember what you have to do, you have to subtract the exponents. So 3 minus 1/2, you can write that as 6 over 2 minus 1 over 2, so that's 5 over 2. So I'll get x to the 5/2 power, and then minus, since there's only a constant in the numerator, and this is x to the 1/2. Since it's in the denominator, I'm going to write it as x to the minus 1/2. Okay, so this is the first thing that we'll want to do when we see functions like this. Always write them as power functions first. That's the only time you can use the power rule. At this point, now that's all we have. It's just power functions, so we're going to go ahead and use that power rule. So remember what we want to do is add 1 to that thing. So that's going to give us 7 over 2. And then if you've got fractional exponents like this, what we're going to have to do is divide by 7/2, but that's the same thing as multiplying by 2/7. So what I think the best way to deal with these is if you've got a fractional exponent, just raise that by 1. Whatever answer you get up here, whatever number you have as the exponent, flip that number over, and then that's what's going to go in front. For the second part, I'm going to do what we did on the last examples, and that is if I've got a constant, I'm just going to leave it alone. I'm going to put my x here, leave a little room for the number I know I'm going to put there, and then I have to think, okay, well, what am I going to get when I raise that by 1? Negative 1/2 plus 1 is positive 1/2. And then remember that what I do next is I take that number and I flip it over, and that's the number that goes here. So if I flip that over, I get 2. Okay, and then let's put the plus c on the end of this. And so my answer here will be 2/7 x to the 7/2 power minus, and now we can multiply these together, we're going to get 4x to the 1/2 power plus a constant. Okay, so that's how we deal with so-called rational functions, integration. Always any roots, write them as powers. You got a couple of things added together or subtracted, split it up, use the properties of exponents to simplify it down to the point where it's power functions. Once it's power functions, use the power rule. Okay?